A propeller provides the thrust to pull the airplane through the air. The propeller generates thrust in the same way a wing produces lift. Most propellers attach directly to the crankshaft and turn at the same RPM as the engine. The efficiency of a propeller is measured by the ratio of thrust horsepower to brake horsepower. Propeller efficiency varies from 50 to 87% depending on how much the propeller slips. A fixed pitch propeller comes in two types. One of them is a climb propeller and the other a cruise propeller. Whether an airplane has a climb or cruise propeller installed depends upon its intended use. The climb propeller has a lower pitch and less drag. This results in the capability of higher RPM and more horsepower from the engine. This increases performance during takeoff and climbs, but decreases performance during cruising flight with a loss of speed. This is similar to a car with only a low gear. The cruise propeller, on the other hand, has a higher pitch and more drag. This results in lower RPM and less horsepower from the engine. This decreases performance during takeoff and climbs, but increases efficiency during cruising flight, a much higher speed. And this is similar to a car with only a high gear. A constant speed propeller allows the pilot to change the blade angle in flight. An airplane equipped with a constant speed propeller has a throttle and a propeller control. The throttle controls the power output of the engine as shown on the manifold pressure gauge. The propeller control adjusts the propeller blade angle to control engine RPM, as indicated on the tachometer. Generally speaking, power increases and decreases should be made in such a way to keep engine RPM higher than manifold pressure, and this is true for most airplanes. This means power reductions should be made by retarding the throttle prior to reducing the RPM. Conversely, power increases should be made by increasing RPM prior to increasing manifold pressure. Set the propeller control to a given RPM, and the propeller governor will automatically change the blade angle to maintain this speed. A constant speed propeller permits the pilot to select the blade angle that results in the most efficient performance. As we've seen before, a low blade angle or decreased pitch reduces the propeller drag and allows more engine power for takeoff. In cruising flight, a higher angle or increased pitch increases engine efficiency. This process is similar to shifting gears in a car. The governor maintains the propeller and therefore engine speed constant by the use of flyweights, which spin with the crankshaft. If the airplane engine speeds up for some reason, say you pitch down, the crankshaft will start spinning faster, and this will cause the flyweights to move outwards because of centrifugal force. This will pull a piston called pilot valve up, as shown by the animation, and allow oil to flow from the oil boost pump to the propeller hub. This in turn will force the propeller blade to a higher angle of attack. A higher angle of attack means more drag is exerted on the propeller, which will slow down and in turn slow down the engine. The flyweights go back to their neutral position and the RPM stabilize back on their previous speed. The opposite happens if for some reason the propeller slows down, say you pitch up. The flyweights this time will move inwards because of centripetal force, pushing the pilot valve down. This will allow the oil to flow back to the sump, as a spring inside the propeller hub will push the propeller blade to a high RPM, low angle of attack, and push the oil back into the system. As this happens, the propeller will speed up again and bring the flyweights back to the neutral position, and the RPM back to their original setting. Keep in mind that this is a non-feathering propeller. In most feathering propellers, the ones capable of auto-feathering in any case, the oil will actually push the propeller blades to a high RPM, low angle of attack to aid in feathering in the case of engine loss.